You're listening to the Effective Statistician podcast, the weekly podcast with Alexander Schacht and Benjamin Pieske, designed to help you reach your potential, lead great science, and serve patients without becoming overwhelmed by work. This is episode with Giorgia Salanti, an interview about network meta-analysis, why, what, and how. That I can give you this interview with Giorgia. She is basically a superstar on the network meta-analysis research side. She has published a lot, she has worked with all the different key stakeholders, has a huge influence in the field, and just is a really, really nice person as well. So enjoy this interview with her, where you will learn about network meta-analysis. You will, if you have predominantly worked on clinical trials, you'll get a very, very different point of view on the field overall, and I'm sure you'll take away a lot of great things. Welcome to another episode of The Effective Statistician. Today I'm speaking with Giorgia Salanti. Hi Giorgia, how are you doing?
Hi, I'm doing well, and thank you for pronouncing my name properly. Most people called me Salanti.
Thanks so much. And maybe we can start with a little bit of your background, how you're coming to the place you're in now, and what were your main statistical research fields up to now.
Right. I am currently Associate Professor for Biostatistics and Epidemiology at the University of Bern, at the Institute for Social and Preventive Medicine, which belongs to the medical school. I have been working in many different places around Europe. So first I studied maths at the University of Athens. And then I did postgraduate studies in applied statistics, epidemiology, and operational research in health at the University of Brussels. And then I went to Munich to do a PhD in statistics at the Ludwig Maximilians University. And then I went to Cambridge at the MRC, where effectively my career in meta-analysis started, because I worked as a postdoc under the supervision of Julian Higgins, and I learned a lot of things about meta-analysis there.
Well, for those of you as a listener, if you don't know Julian Higgins, he's the first author of the Cochrane Handbook in terms of the methodological things. So
he's the editor of the handbook and has contributed tremendously to the field. For probably most people would be familiar with the I-squared measure for heterogeneity. That's something that Julian introduced to the field. And after Cambridge, then I went back to my home country, Greece, and I worked at the University of Ioannina for 9 years. And then I decided to move on, and the last 4 years I am here in Bern, working still in evidence synthesis, primarily in evidence synthesis.
Awesome. Thanks so much. So today we'll talk about network meta-analysis, why, what, and how. And so let's start a little bit with your why. And maybe you can also speak to that, why you're personally so much interested in network meta-analysis.
Well, I have to confess that initially that was by chance. Because I started working in 2003 in Cambridge, as I said, and the project was about evidence synthesis from multiple treatments. And this is how I was introduced to it. It was an assignment I have to go through with. But after a year or so, I I decided this is really a very interesting field, so fascinating, both methodologically, but also from the application point of view, because you can answer really very important clinical questions with it. And the maths behind it are fun too.
That's very good. Yeah, I think that's quite an interesting way to feel passionate about something. The more you learn about something, the more your passion can grow into that. And I completely agree. It's a really, really important field because, especially in areas where there's multiple treatment options, so maybe 10 or 20 treatment options, it's pretty much impossible to have direct comparisons for all of these. And even if you would have direct head-to-head studies for all of these would probably have come from different sources, and it wouldn't necessarily came out that there would be a nice order and ranking you would get from that. But, looking into them, you could see something like treatment A is better than treatment B, and then in another study, treatment B is better than treatment C, and in a third study, treatment C is better than treatment A again. So you would have this kind of full circle, and then in the end, you don't know what's the best treatment. And so this is where network meta-analysis come in and are quite useful. Where do you see from your end that why are network meta-analysis also important beyond this kind of, let's say, clinical thing?
No, I have to say I haven't been working in much in fields outside the medical and clinical research, and it's it's a quite a big field already, and there are so many applications. I didn't have time to look anything outside medicine and clinical research.
Yeah, so one area where it plays a big role, and I think that's also why the UK is so one of the areas where there's so much research, is that it directly feeds into the economic evaluation of new drugs. So NICE uses these network meta-analysis to feed into the economic models that they use, and lots of other countries have followed that approach. So around the world, network meta-analysis are really important for reimbursement decisions. So that's, not just from a, let's say, purely medical treatment decision point of view. This is really important, but it's also from a cost effectiveness point of view, very, very important.
Yeah, absolutely. And on there are recent developments in fields like diagnostic test accuracy comparisons and prognostic factors comparisons, but I think they are still in their infancy.
No, okay, but that is a nice area to watch out for, whether we'll be able to use a network of indirect comparisons there as well. But let's first start into network meta-analysis. So if you would describe to a new starter that has never kind of heard about this term, what are all the different steps that you need to go through to come up to such a nice result where you can compare multiple treatments with each other?
Okay, would that person be a statistician and clinician or a lay person?
A statistician.
Okay.
Pretty much all of our listeners are statisticians. So.
Okay, good. So, well, the first thing probably is to work together with an expert in the field. Statisticians cannot do by themselves a network meta-analysis, because the point is not just to put data together. The point is to put them in a sensible way, to put together data that fit together and make sense, and then interpret the results under the light of the clinical context or the research question that was initially put. So network meta-analysis are triggered by interesting research questions that either clinicians or their patients have. And the most critical question that actually is raised by patients and clinicians at the point of care is, what is the drug of choice for a given condition? For example, we do not care whether antidepressants are better than placebo. Of course, we do care, but not just that. Once we have proven that antidepressants are better than placebo, then we want to know whether they are different, whether a particular antidepressant is better than the others. And then the clinicians and patients come with the question, can you tell me which antidepressant has the better profile in terms of efficacy and acceptability? And then, so we start an NMA with a research question which should be framed very carefully in terms of PICO, in terms of patients. What patients are we talking about? Interventions, which interventions we want to compare, and control, whether we want to involve in our decision making or in our data sets, we want to involve legacy treatments or placebo or treatment as usual, things like that. And I will come back to that in the methodology, because people might be wondering, why do you include placebo or treatment as usual or some other treatments in the data set if these are not real options in practice? And then once you have decided about which treatments you want to compare and what are the non-active treatments or legacy treatments that you want to involve, then you have to define the outcome. So what does better mean for an antidepressant compared to another? Is the one that provides the best chances to respond to the treatment? How is this response defined? And do we care about side effects, specific side effects, all side effects? Do we care about treatment discontinuation? All that usual considerations that come in a pairwise meta-analysis, let's say. But these are very, very important to be defined very carefully at the start. And to my experience, that's the longest and most important phase of a systematic review and network meta-analysis. Like, get your team together, discuss with clinicians and experts in the field, and get things right from the start with respect to the PICO. And then, and then the librarians step in and they develop a search strategy that reflects your inclusion and exclusion criteria as defined in the PICO. They get the relevant studies, the research.
Just a note. If we talk about in-exclusion criteria, these are not in-exclusion criteria for kind of patients, so that we know from the patient, from the clinical trials, but these are basically in-exclusion criteria for the publications that we want to include, isn't it?
Exactly, it's for trials. The unit of analysis or the unit of interest in meta-analysis and network meta-analysis is the study, not the patient. Unless, of course, you're doing an individual patient network meta-analysis, in which case we are talking about something else.
Yeah.
So, but let's focus at the moment and constrain ourselves to the most common case of evidence synthesis from aggregated data. So you are searching for the publications, you extract the data, or the data extraction team gets the data out of the papers, again, and not only the outcomes or their characteristics, but also they evaluate the studies with respect to the risk of bias, and there are many tools that can be applied to that. To that purpose. And then finally, once the data is out, the statistician takes them and does some initial checks as usual. And then we need to, the first thing to do is just to look at the data set by plotting what we call a network plot. I guess most of the audience would have seen a plot like that. It's like a network where the nodes represent treatments found in the database, and each link represents at least one direct comparison that features in your data set.
Yeah. These are always kind of the first graphs you see in these network meta-analysis. And I think they also represent why we talk now about network meta-analysis. Very early in the development, we also talked about mixed treatment comparisons. So there's a couple of different synonyms, but I think nowadays network meta-analysis is kind of the standard phrase that we use for that. And
yeah, you're right. Yeah, previously it has been called indeed mixed treatment meta-analysis or multiple treatments meta-analysis, but now we all accept the term network meta-analysis, which is a relief. So we know we are talking about the same thing. Yeah, and then once you get the network, and you need to understand the structure and see whether it's a star-shaped network where everything is compared to a common comparator like the oldest treatment or maybe placebo, depending on the field. And then you go ahead and you do a first synthesis of data with the aim actually to do a test to see whether the data fits together or not.
So in there you would first do all the, let's say, pairwise meta-analysis first. So if you have, let's say, multiple treatments that compare treatment A to placebo, you would first combine all these and have a look into that?
Yeah, well, again, it depends on your data. Some very sparse networks where you have only a couple of studies per comparison, then it might be of limited usefulness to do pairwise meta-analysis. But in most cases, absolutely, you will start by doing a traditional pairwise meta-analysis, primarily to understand your data better.
Okay, to see whether there's any heterogeneity already on that level. Yeah.
Yeah, and then I'm skipping ahead because what I'm usually doing is to use the test for inconsistency that I will describe later on. These are tests that tell you whether the indirect evidence and the direct evidence agree in statistical terms, whether, they give the same estimate more or less. Because to my experience, this test has been a very useful tool to detect data extraction errors.
Okay, so basically inconsistency for those that are not so familiar with the term is if you have a head-to-head study of A versus B, and you're also looking into indirect comparisons of A via C to B, then both these comparisons, the indirect and the head-to-head one, should give you the same, or at least approximately the same result. Then it's consistent, otherwise it's inconsistent. And yeah, well, how much of the difference is then inconsistent or not? That's another talk. But how do you if you see then something about their being inconsistent, and that's actually a listener question from Paolo that I received upfront to this interview. What do you do then if you find these inconsistencies there? What would be your next step?
I ask the team that extracted the data to go back and check the comparisons that I suspect are introducing inconsistency. Empirical evidence by R.G. Veroniki, published a few years ago, has shown that inconsistency is more likely to occur in small triangles. Triangles, the evidence composed by A, B, A, C, and B, C studies, as you described in your theoretical example. If this triangular loop has one comparison informed by a single study, say we have 10 AB, 10 BC, and one AC study only, then this AC comparison informed by a single study is very often susceptible to introduce inconsistency because of data extraction error.
Okay.
So I detect cases like that, and then I ask the data extraction team to check. And very, very often, this has revealed that the data has been extracted in the wrong direction. Instead of putting a negative mean difference, they have put a positive mean difference, because instead of putting A versus C, they put C versus A.
Or messing up the odds ratios, these kind of things. Yeah, I've seen that as well. Yeah, so it's quite common.
Yeah, so that's the first thing to do. Yes.
Okay, very good. And if these are still correct, and if the team comes back to you and says, well, we double checked everything and everything is correct from a numbers perspective, what would be your next steps then?
Well, once I see that the data is correct, then actually I go back. I go back to the network, and then we plot descriptive statistics of effect modifiers by treatment comparison. So in the protocol of the network meta-analysis, we should have already described what are the susceptible effect modifiers that can introduce disagreement between direct and indirect evidence if they are imbalanced. So, for example, if you have the triangular network that you have been describing before, and the targeted population is adults, but all AC studies have been undertaken in geriatric populations, which of course are adults, so that's why they are included in our data set. But it can be that the age is an effect modifier for the involved treatments. That means that the relative advantage of one treatment over another changes across age groups. Then this difference in age between AC and AB studies will introduce inconsistency.
Okay. Yeah, I see that. And so in the protocol, you already have defined for which treatment effect modifiers you check. And I think that is also where the expert opinion is really important, that okay, these are the things that we need to look out for. These are the things where we need to check whether, for example, head-to-head studies have different inclusion criteria and maybe placebo-controlled studies, and these to be aware that these could lead to inconsistencies. Very good. And I really like also that you have a graphical approach for that, because I think whenever you want to compare treatment effects and together with the confidence intervals, it's really nice to have these graphical approaches, like, for example, forest plots. Do you use forest plots as well for this approach, or how do you visualize these kind of things?
Yes, I do use forest plots, but not the traditional forest plot where each study is represented. But I use forest plots where I plot the direct, the indirect, and the mixed evidence to gauge any discrepancies between direct and indirect.
Yeah. I like that very much, because then you can also see in which direction it goes, whether the direct evidence points to a bigger or smaller difference, things like that. Yeah. And I was asking for that because that was another question from Paolo that I got before the interview. Mm-hmm. By the way, as a listener, if you're want to also give input into interviews that I'm doing, or any other podcast episodes that we are recording, watch out for what I'm posting in the Effective Statistician LinkedIn group. And I'll regularly post when there's an interview coming up or when there's a podcast recording coming up, and then you'll have the opportunity to give a little bit of input into this. So that would be really nice. Okay, Georgia, let's come back to the NMAs. So now we have checked for the inconsistencies. and we have looked into whether also data makes sense and all that. We have the network laid out nicely. What's the next step then?
Well, assuming that there is no reason to suspect that the data does not fit together, and direct and indirect evidence all around is what we call consistent. So they are in agreement, the different sources of evidence. And just opening a parenthesis, there are many statistical approaches to that, either the graphical approaches that I just described, or particular tests like the separating indirect from direct evidence, known also as node splitting. There is a numerical test also, the design by treatment test that tests whether the network fits together as an entity. And so once you have applied this test and you have also looked at the distribution of effect modifiers across the network and you made sure that everything is in agreement, then you move on and you do the synthesis. And people can use different software to run all that. What I use nowadays is NetMeta package in R, programmed by Guido Schwarzer and Gerta Rüker. And but most of the time I use self-program routines in JAX run from within.
So the package from Gerta Rücker, is that the frequentist approach?
It is a frequentist approach.
And JAX is, of course, the Bayesian approach. Okay. Is there any, do you have any kind of personal preferences between these?
It's not a personal preference. It has to do with the analysis that needs to be done. If inconsistency is found, or if the distribution of effect modifiers is a bit different across the comparisons, then depending again on the effect modifier, you might need to apply network meta-regression to see whether agreement would improve by sort of adjusting for differences in that effect modifier. And unfortunately, NetMeta doesn't do network meta-regression. So you have to do that in a Bayesian framework.
So basically, in your protocol, you would need to basically upfront plan for all kind of different findings that you may see in your data, so that you can be flexible in terms of what analysis approach you take in the end. And you don't go basically into the data, then see some things, and you need to change your protocol. Then you move forward, you see another problem with the data, you change your protocol again. But I think you can't foresee any data problems that you might step over, isn't it? So if you think, for example, well, there is, this overall, it looks like a connected network, but there's this one study that basically is in the center of that connects everything, and that is somehow weird. And that leads to, all kind of different problems with the overall network. Things like that, you can't all plan for that. So do you have some kind of changes to the original approach kind of section in your protocol or in your results then in the end?
Well, I think that's a fairly common situation that people, when they publish their final review, they include also a section like changes from the protocol. If not a section, just a note somewhere that, look, we have promised to do that or that, but we did something different because of that observation.
Okay.
I think that's legitimate. As long as people are transparent and reporting is clear, then I don't see any problem. Protocols, they are meant to improve transparency and guide people and being a trail that we are supposed to follow, but they are not there to bully us or to tantalize our analysis. If we feel that it's scientifically justified to change things from the protocol, we shall do so, but just report that transparently and give the reasons why you did that.
Yeah, completely agree. I think that is a much more feasible approach, and it's also transparent. So I like that approach very much. In terms of going back to the steps, so now you have done the synthesis. As you just described, maybe you even have done some additional meta-regressions. What's then the next step? Are you now completely ready?
Yeah, well, the challenge is to present the results in an easy to digest way. Because usually you have a lot of treatments, a lot of comparisons, and a lot of outcomes. And the multitude of information produced by network meta-analysis, it's not always easy to digest and distill a concrete message out of it. There are on the top of the effect sizes that you might want to present, which is already a difficult task if you have many treatments and many comparisons of interest. You might want to present ranking of treatments. And to this purpose, they are metrics like the SUCRA, the surface under the cumulative ranking curves, or other probabilistic metrics like the probability that one treatment is better than the other, or it's better than the other by a certain amount. Then you need to present that too, or you might want to find another clinically meaningful way to show your results to the clinical or lay audiences.
Yeah, and I think this is indeed quite a big challenge. So if you, for example, look into the antidepressant area, where you've done a lot of research, and you were also involved in this landmark paper by Cipriani that looked across lots of these compounds with, I think it was more than 140 studies included. It's quite a challenge to condense all that into a reasonable research paper that is understandable. And I think it's a challenge to find a good balance between having all the details there, and on the one hand, having all the details there, and on the other hand, having a good, reasonable, digestible paper. And also, as a statistician, very often want to know exactly kind of all the details, see all the additional sensitivity analysis that were done, all the inconsistency checks, all the kind of these things. It's not really feasible to include that in the main part of the paper, probably just in the some kind of electronic supplement form. And the main part of the paper, especially if you have higher-end journals, you can only include a couple of figures. If you have only, let's say, 3 figures in such a paper, what would you recommend to include there?
Before answering your question, just to go back to what you said about the antidepressants paper, there were 522 studies.
Wow, okay.
big network, and 21 antidepressants plus placebo. So you can imagine it's a lot of information to present. And about the appendix, our appendix is more than 100 pages long.
Yeah.
So, if there are 3 figures of what I would present, it's practically what we presented in this paper in the Lancet. The first figure is certainly the network plot. Mm-hmm. People need to understand what is out there.
I think that is really good because it gives you directly kind of the evidence that you have for each treatment, but it also directly lets you see what are the in which part of the network is you have a lot of evidence and where the evidence is really just sparse. Yeah.
Yeah. So figure 1 is pretty much always the network plot. So in that paper, we had 2 network plots on figure 1 for efficacy, one for acceptability. And I encourage statisticians to plot these networks by making the best out of the graphical information that they can convey with. Like, for example, plotting the nodes proportional to the number of patients randomized in that node. So, for example, in our network, the placebo node was really massive compared to amitriptyline node because there were like 20 times more patients randomized to placebo than to amitriptyline, say. And then the links, which represent direct comparisons, should also be proportional, say, to the number of studies. And maybe you can also color the links and the nodes according to the risk of bias. So, for example, the placebo node, which is a very large node, could be presented like a pie chart where red represents the proportion contributed from high risk of bias studies, green from low risk of bias studies, and yellow from moderate risk of bias studies.
That's a nice way of thinking about it. So basically you incorporate much more than just the network into that thing, but also you see how much, how good the quality is.
Yeah. Mm-hmm. Exactly. And then figure 2 is a forest plot alike presentation of the effect sizes. Usually the effect sizes against a common comparator that makes sense. That could be, for example, placebo if included in your network, or could be the oldest treatment, a reference treatment, for example. And then again, please try to make the best.
And you can also sort that forest plot, isn't it?
Yeah, exactly. I was about to say that you can make the best out of it by presenting the interventions or the drugs not in alphabetical order, but maybe according to their rank, like from the best rank to the worst rank.
That's nice. And then you do that for both outcomes next to each other, so you can directly see kind of how ranks might change if you have for the different treatments. Mm-hmm.
And you can alternatively in the appendix or in the main text, you can present the league table. Usually journals do want the league table in the main publication, not in the appendix. It's a very busy table that has on the diagonal the name of the interventions, and in the off diagonal the relative treatment effects. So basically you have the relative treatment effect of any intervention against any other intervention involved in the network.
Yeah, and if you have that table and you have 2 outcomes, you can use the upper right-hand side for one outcome and the upper lower left-hand side for another. Yeah.
Exactly. That was figure 4 in our publication. And then the final figure that I also find quite useful is a 2-dimensional plot using the main efficacy and the main acceptability or safety outcome. So on the horizontal axis, put the odds ratio for efficacy, say, and on the vertical axis, the odds ratio for acceptability. And then its drug is represented by the efficacy versus acceptability odds ratio. Mm-hmm. And you can also plot the confidence intervals.
So basically you get these little crosses across this plane. Yeah, I like that also. I have also seen that this was done for the Sucra. And to be honest, I'm not a big fan for that, because if you have odds ratios then or risk differences or something like this, then it's pretty easy to kind of compare it. But for the Sucra, you very easily lose the the meaning, because the for sucra you can have huge differences. Because just by the ranking, it's if you have all of the drugs are very, very similar, let's say from a tolerability standpoint, but there are huge differences from efficacy standpoint, you always have, of course, this forced ranking. And so by using a sucra in such a plot, you would overemphasize the differences on the tolerability side versus the differences on the efficacy side. However, if you use the odds ratios or the risk differences, then you can still see how clinically meaningful these differences are. And so I really like your approach there. And coming back to the table with all the different individual comparisons in there. That is also where you could add shading or color coding for any inconsistencies as well, isn't it?
You could put, you can color the cells any way you like. You might want to color them according to the risk of bias of the study's contributing evidence, or you might color them according to the credibility, and we will come back to that maybe later, I hope, or according to the inconsistency, or according to heterogeneity, any component you like.
So with that, the table itself also becomes some kind of graphical tool, which is really nice. Okay, in terms of the table, how would you sort the table? Would you also sort it by ranking according to one of the two outcomes?
Usually, yes. In our Lancet publication, it was alphabetically. Because it's easier to find the drug you're interested in when you're reading it, and because it's a quite busy and big table, maybe it would be when you have many drugs or many interventions in the diagonal, better to sort them alphabetically so people can easily go to the cell and column and row they are interested in and find it more easily instead of ordering them by ranking, be it the odds ratios or the sucras. By the way, I want to come back talking about sucras to the statement you made about the sucras and how they would amplify the differences between the interventions. That doesn't have to be the case. Whether sucras and odds ratios, the mean odds ratio we are referring to when it comes to ranking, whether the ranking or sorting the drugs according to the mean odds ratio versus ranking them according to sucras, whether these two rankings disagree or agree depends a lot on the precision, so how much information we have all together in the network, but also the differences in precision. If we have drugs that have only a couple of studies, small studies, and all other drugs, they are informed by many large studies, then there will be important disagreement between sorting according to the odds ratio or sorting according to sucra. But if we have more or less balanced information on the network, as it was the case using in the antidepressants example, then the two rankings should agree. Note that ranking using the mean odds ratio completely ignores the uncertainty around this odds ratio, whereas ranking the drugs using the sucras, it accounts for, let's say, the confidence interval or the imprecision with which that point estimate, that odds ratio is accompanied.
Yeah, that makes a lot of sense. It's kind of course, if you have just one treatment in there that has very little evidence, it's just this random fact that these can easily be outliers to the top or to the bottom the network, and so they can very easily be there, but through the through cross they are kind of pulled in a little bit, and instead of just looking into the ranking, so to say.
That's why I always say that sucras and ranking probabilities and treatment hierarchies, they are a nice first step to look at the results, but it's only just the first step. Then you should look at the odds ratios against placebo or the common comparator, or really take the time to try and digest the full league table.
Okay, very good. Okay, so now we have presented the results. What are the remaining steps for the NMA?
Well, to see whether you believe them. The results are just numbers. How much do you believe these numbers that you see on the paper or on your screen? And that brings me to cinema, which is a framework for evaluating the confidence in network meta-analysis results. Maybe the audience is familiar with the grade system, which is a system to evaluate the credibility of results from, say, pairwise meta-analysis. And they have extended it to the network meta-analysis, but we have come up within the Cochrane collaboration, we have come up with an alternative system, which, however, we have implemented in a user-friendly, I hope, software, which is free. It's called Cinema. I will send you the link so you can put it down from the podcast and people can access it. And does pretty cool graphs like the one I told you before. Nice. That you can plot each node, which represents a treatment, in a pie-like plot, like with percentages of information from low, moderate, or high risk of bias studies. And in order to evaluate the credibility of the results, we have the following components. You evaluate them according to the within-study limitations, like within-study biases, risk of bias. The classical tools from the Cochrane collaboration are used to evaluate whether a study pertains to high, moderate, or low risk of bias. And then according to the indirectness relates to what I described before. If you're interested in adults, but the study reports results from geriatric populations, then you sort of indirectly answer the question you have been asking. And then we evaluate the results according to reporting bias, so whether there is the suspicion that some of the comparisons have been subject either to publication bias or to selective reporting bias. And then we evaluate them according to heterogeneity and to inconsistency. Obviously, the larger the heterogeneity and the larger the inconsistency, the less easy the interpretability of the results under different contexts.
Awesome. Very good. And
then I forgot, it's also imprecision. Large confidence intervals are in a way penalized in terms of credibility, because if you have a very large confidence interval, then this doesn't allow you to make any sensible, to draw any sensible clinical conclusion, like whether you will give that intervention or not to your patients.
Okay, yeah. And I think that's important. It's if you want to make a recommendation for physicians or for payers or for patients, you need to account for not only for the treatment effects that you find, but also on the credibility and the measured by the confidence intervals, as well as other sources of potential bias there. Okay, very good. So then we are now at the end. Very good.
Yeah.
If so, for the listeners that start out completely new about a network meta-analysis, do you have a recommendation for what they should read first?
Yes, I think they should start small by reading the newly updated chapter in the Cochrane Handbook, which describes network meta-analysis in a non-technical way. But to my appreciation, in a quite important way to understand the essence of network meta-analysis, not just the maths. And then once this is done, then they could move into the technical literature. There are many tutorials published in journals like Research Synthesis Methods or Statistical Methods in Medical Research and Statistics in Medicine that they describe the technicalities behind network meta-analysis. Many books for evidence synthesis do include chapters on network meta-analysis. I could send you later the links if you want. And then there is a recently published book by Sofia Diaz and colleagues, fully dedicated to network meta-analysis, and it's a more on the technical
Awesome.
side. And of course, there are many network meta-analysis courses taking place year-round in various places, several of which I am involved, like in Oxford or in Wengen, or also here in Berlin.
Okay, very good. We'll put all the links to these different resources into the show notes. So just check out the effectivestatistician.com, look for Georgia's name, just search for her and you'll easily find the episode, and there you will have everything. Awesome. Thanks so much. By the way, there's also some nice resources on your university homepage. We'll link to that as well. Awesome. Thanks so much for this really, really nice chat about network meta-analysis. I very much liked how we stepped individually to the different network meta-analysis. We touched on a couple of the key assumptions that we need to check around in network meta-analysis, how you can present, and also which tools you can use to run NMAs, and summed it up with a couple of references. Thanks so much, Georgia, for that.
Thank you too. I enjoyed it very much.
This podcast is created in association with PSI, a global member organization dedicated to leading and promoting best practice and industry initiatives. Join this awesome community today to further develop your statistical capabilities with access to the video-on-demand content library, free registration to all PSI webinars, and much, much more. Visit the PSI website at psiweb.org to learn more about it and become a PSI member today. This show was created in association with PSI. Thanks to Rain, who helped with the show in the background, and thank you for listening. Please visit theeffectivestatistician.com to find the show notes and learn more about our podcast to boost your career as a statistician in the health sector. So, reach your potential, lead great science, and serve patients. Just be an effective statistician.